Hello everybody and welcome to our kitchen. This is going to explain the vocabulary that goes with this solutions unit. Alright, so we'll start off with solution. A solution is a homogeneous aqueous mixture. Alright, homo means same, right? Hetero, different, homo, same. So it's the same throughout. So a mixture that is the same throughout. In other words, something has dissolved into it. An aqueous solution is a specific type of solution, a solution in which the solvent is water. All right, so solvent may be a new word as well. Solvent, an aqueous substance in which another substance is dissolved or spread homogeneously. There's that same homogeneous word. So that means whatever you mix into it is spread evenly. Okay, and then finally solute, a substance that is dissolved or spread homogeneously in another aqueous substance. So I have a cup of water, some lemonade mix, and another cup of water. The water is going to be my solvent. In other words, the water is the base for what I am making. It will dissolve something in it. The lemonade mix is going to be my solute. Look at the difference between those two words. Solvent does the dissolving. Solute is dissolved in the solvent. So solute is the lemonade mix. Solvent is the water. Together, they're going to make a solution. So if I take, let's see, according to my directions, since I have a cup, I need a rounded tablespoon. So if I take a rounded tablespoon of solute and put it into this water that is the solvent and dissolve it, I have made a lemonade solution. So the solvent is water. This is just water, right? The solute is the powder. The solution is the powder dissolved in the water. The solvent plus the solute equals the solution. The water is the solvent. The lemonade mix is the solute. The lemonade is the solution. Solvent, what does the dissolving, the base or the medium, the main component. The solute, what gets dissolved. Solution, solvent plus solute equals solution. Okay, this one is an aqueous solution because it is based in water. So an aqueous solution is a solution in which the solvent is water. Okay, now next let's go to solubility. Solubility, the ability of a substance to dissolve in a given solvent. So we mixed up the lemonade mix into the water, and now if we look on the bottom, you can see that it has all dissolved. It is all a liquid. There is no longer a solid present. The solid was dissolved. It did not melt. It disappeared because it broke apart into little pieces and it spread evenly throughout the water. So the water particles are holding it up evenly throughout that mixture. So this is soluble because it dissolved. So soluble, able to be dissolved in a given solvent. The lemonade mix is soluble. Here I have just a glass of tap water, and I'm going to add some pepper to it. Okay, you can see the pepper floating on top. So if I stir this, will it disappear? Will we have just kind of a brown water instead of a pink water like we have over here and not have a solid anymore? Let's find out. we can see the same pepper flakes that we saw before still floating in the glass. So it did not dissolve. It has just mixed in. So this lemonade that was soluble, this is a homogeneous mixture. It dissolved. This is a heterogeneous mixture. It did not dissolve. No matter how long I stir this, no matter how much time I give it, or if I heat it up or whatever, the pepper will not dissolve in the water because the pepper is insoluble. So solubility is the ability of a substance to dissolve in a given solvent. The lemonade mix has high solubility because it is soluble. This has low or no solubility because it is insoluble. Okay, let's review. Solvent plus solute equals solution. The solvent is what does the dissolving. The solute is what gets dissolved. The solution is what is made, the two mixed together. If it's an aqueous solution, then the medium or the solvent is water. Soluble means it will dissolve. It disappears in the water. There's only a liquid. There are no solids floating in it. Insoluble, it will not dissolve. It has a solid in it. Solubility is its ability to dissolve. This is highly soluble, high solubility, low solubility. All right. Here I have some water molecules. Okay, we always recognize the Mickey Mouse water particle. And what we may not know is that the Mickey Mouse particle is what is called polar. So polar describes a molecule in which one or more atoms is slightly negative and one is slightly more positive. So this is a polar molecule. So it shares a charge. So the ears are positive. This is easy to remember because nobody comes home from Disneyland with a Mickey Mouse chin. The positive part of Mickey must be the ears. We've got ears. Say cheers. Here's our positive part, the ears. And then no one comes home with a negative Mickey Mouse chin. No one has returned from Disney with one yet. Positive ears, negative chin. So because these molecules are polar, because they have polarity, they interact with each other accordingly. So polarity, unequal sharing of electrons in a chemical bond. So this negative chin, we know that opposites do what? Give you a second to think. Opposites attract. So that means this negative charge is going to attract a positive charge. And when these two attract, this makes a weak hydrogen bond. You have learned about hydrogen bonds before when you took biology. The DNA unzips. Whenever it unzips, that is breaking the weak hydrogen bond between the two strands so that it can be copied, and then it zips back. So it's like a weak little magnet that's made. So this is the same kind of bond. This weak hydrogen bond is the bond between that negative and positive. So we've got negative to positive, positive to negative, positive to negative, and so on and so forth. Oh, that lined up good there. So opposites attract, right? We've got positive next to negative. This is why water expands when it freezes, why you have to leave a little bit of room in the top of the bottle so it doesn't pop in your freezer. This is why everything else, whenever it freezes, it gets smaller, except water, because of these hydrogen bonds, it arranges these in a way that actually expands it and makes it bigger. And it's all of this hydrogen bonding, the negative attracted to the positive. So when we say we have a polar molecule, picture if you were given a cookie and your mom said that you and your sister are to share the cookie. So that means if you're going to share it, it's going to be a covalent cookie because covalent means to share. So if you half that cookie perfect, then you have a covalent cookie. But if you decide you're going to get a big piece of cookie and your sister's going to get a little piece of cookie, that is now a polar covalent cookie. The cookie is being shared, so it's covalent, but it's being shared unevenly, so it is polar. So polar covalent, unequal sharing, polar covalent. Okay, so if you have some salt, and salt is sodium and chlorine, and you dissolve the salt in the water, so this gets dropped in, and the water molecules go and they bump against it, and they break little pieces off and dissolve them. So now you've got these positive and negative ions floating around. So now that this is negative here, this is not polar, this is just negative. All the positives are going to spin around towards it. So all those Mickey Mouse ears point towards that negative particle. So what's going to happen to this positive particle? How should I spin it? Positive, negative. So this is going to come here and be surrounded by the Mickey Mouse chins. So we've got the hydrogen bonds messing with each other there. And we've got these and those. And we've still got, we'll just take an extra here. Negatives pointing there, ears pointing there. And we can have a weak hydrogen bond here. Okay, so you have your negative one with all the positives facing it, your positive atom that got broke off of here with all the negatives facing it, the water molecules still interacting with each other, everything pointing the right direction based on charges. Let's review. The solvent does the dissolving. The solute gets dissolved. The solution is the solvent plus the solute. If it is an aqueous solution, then it is a solution where the base or the solvent is water. If it is soluble, it will dissolve. If it's insoluble, it will not dissolve. High solubility, low solubility, or no solubility. Polar, uneven, covalent sharing. So polar means it has a plus side and a minus side. Water molecules have positive ears and negative chins. If you dissolve ions into that, they will line up accordingly. Weak hydrogen bonds are made from the plus and minus charge that makes water droplets act mostly the way that they do. These interactions are called intermolecular forces, forces of attraction or repulsion that act between neighboring particles. So all of this is showing the intermolecular forces. And then, forgot I had a card for hydrogen bonding. Hydrogen bond, an attraction between a hydrogen atom that is covalently bonded to a highly electronegative atom. In other words, oxygen or nitrogen, and another highly electronegative atom to which the hydrogen is not covalently bound. Okay? It's just that attraction between those polar molecules. All right, finally, we have capillary action. Capillary action, the movement of a liquid substance along a solid surface or up a tube due to the molecular forces acting between the liquid molecules and the molecules of the solid. So these are some plants that Adam planted, and his little sister Amy decided to give this one a little extra water, and now there is standing water in the little cup, and it's really way too much water, and it's got a pretty good chance of killing the plant. So I need to get some of the extra water away from this plant. If it was a little more, maybe I could pour some of it off, but then I would lose some of the soil and it might disturb the roots. I really just want to get the water off of it. So I'm going to use capillary action to absorb some of this water. So when I put the end of this paper towel, you can see it pulling up the water, defying gravity, bringing that water straight up into the paper towel. That is capillary action. It's moving the liquid along a solid surface. Okay, our solid surface is the paper towel. This also works with a tube, but I didn't have that. I just had the paper towel. And the molecular forces that cause that to be drawn up. So if I go on the other side, pull up that water, maybe I can rescue that little plant and not have it sitting in standing water. And I didn't have to pour off any of the soil. It just absorbed the water. And now, maybe that little plant has a chance of surviving.